Welcome everyone to our APES podcast. My name is Conor Schmidt. I'm a PhD student in Texas Tech University, Region 5, and today I'll be the main moderator of this session. Today we have a great professional on power system area. It's Professor Mats Almazaki. He's going to be speaking about engineering innovation in power and energy systems from bulk megawatts to nimble kilowatts. Just to remember you all, this session will be more discussion. We don't have a main presentation, but everyone's going to bring some ideas, questions, and then we have some discussions about the main topic. So feel free to use the chat. And also, if you want to make a voice question, we have our host here. You can just raise your hand and the host can go there and unmute yourself and you can bring some ideas and do discussion with us here. So enjoy this moment to take all your questions out and learn a little bit more about the topic. This is a really hot topic now, mostly now with the Texas outage, how we can use the innovation and also controllability of our loads just to improve our system resiliency. So this session also makes part of our monthly podcast. So Region 1 to 7, we have been developing this podcast monthly. We are just bringing some high-level speakers to discuss about one specific topic and give you this opportunity for all the students from Region 1 to 7 mainly to take your questions and discuss more about this technical topic, okay? So thank you very much, you all. And mostly I would like to thank you, Matt, for your time and consideration with us today. It's a great pleasure to have you here with us. We know that you are really engaged young professional volunteer, so it's really nice to host you with us today. And just a quick bio from Matt. Matt Ron Almazaki is an assistant professor in the Department of Electrical and Biomedical Engineering at the University of Vermont, co-founder and senior strategy advisor at startup company Packetize Energy, and chief science of DOE Pacific Northwest National Laboratory, Optimization and Control Group via joint appointment. At the University of Vermont, he's director of the Core Control Optimization of Renewable Energy Systems Lab, where his research group's interests lie in the intersection of power systems, mathematical optimization, and control systems, and focus on developing scalable algorithms that improve responsiveness and resilience of power energy systems. He was awarded the Outstanding Junior Faculty Award by the University of Vermont, CEMS, in 2016, and the NSF Career Award in 2021. At Packetize Energy, he has led strategic partnership, technology development, and business development initiatives. Prior to joining the University of Vermont, he was lead system engineer at Root 3 Technologies, which developed energy as a service, SaaS, software to optimizing energy, multi-energy systems. Before that, he received his PhD from the University of Michigan in electrical engineering systems in 2013, and a dual major in electrical engineering and applied mathematics at the University of Cincinnati in Ohio in 2008. He also serves as a chair of the IEEE PES SBLC load subcommittee. When he's not working energy problems or teaching, he's spending his time with his amazing wife and their 3 young children. So thank you very much, Matt, for your time. I'm really excited, especially myself, I'm really excited for this session. I have a lot of interest in your background field. So before we start our main discussion, I'd like to invite you to just briefly tell us how was your path in the academia and how you get in touch firstly with the startups and how did you create and have with the idea about Packetize company. I think you are on mute.
There you go. That's
fine.
2021 for you. And so first of all, thank you all for hosting me today and for inviting me to be on this podcast. It's a huge honor to be able to speak with students from across the world, basically, and hopefully, after this hour, we're all just a slightly bit smarter than what we started with, and then I'll be very excited. So your question is a very good question. It's also a very complex question because it's asked me how I got started and then also about Packetized. And so maybe, my path through academia, maybe I'll just take a very brief detour. And first off, I have to be very honest. Unlike many people in PES, I actually have never ever taken a power systems course for credit. And so my path to power systems was not straightforward, it wasn't obvious. I entered graduate school wanting to basically work on autonomous cars. I thought that would be a really cool thing in the future, and it is a pretty cool thing. It just isn't what I'm working on these days. And the reason for that was pure luck. So when I came to the University of Michigan, when I enrolled in the University of Michigan, there was no power systems program. It had been shut down, just like almost all power systems program in the US, because obviously we didn't need it. Power system wasn't that important, until blackouts happened, like the one in 2003 in New York. And just recently in Texas, we have now reinforced the importance of power systems. And so every time we have disasters, we realize how much we need to learn about power systems. And so when I was a PhD student, I was really focusing on automation, autonomy, optimization, and control. And from that perspective, power systems is a wonderful place wherein you can use control of batteries, you can use control of wind turbines that can curtail energy, you can use control of electric vehicle chargers to manage demand, to really help ensure that the grid stays reliable during certain events. And so when I was a PhD student, I really focused on optimization and control. And after a couple of years with my advisor, I think he started to trust me a little bit. And then he one time received an email from somebody wanting to start up a company. And they needed someone to solve optimization problems, and specifically unit commitment and economic dispatch problems. And I was like, yeah, I don't really know what the unit commitment problem is because I'm not a power systems person, but I know optimization. And so I worked with this startup company before it became a startup company by turning my optimization understanding and learning about unit commitment and economic dispatch, and really focused on solving a unit commitment problem that was not generators related, but was related to chillers and boilers on very large industrial energy facilities. And so managing boilers and chillers or combined heat and power plants on campuses or in airports or in industrial manufacturing centers is not that different from managing large swaths of generators on a transmission network. And so I ended up optimizing batteries, combined heat and power plants, boilers and chillers, which represent heat, cool, and electric demand, for customers that consumed megawatts or $50 million energy budgets. So these were massive industrial customers. And that was my first experience of a startup company. We did a little bit of work on behalf of the University of Chicago. We worked with San Francisco Airport, worked with the University of New Mexico, basically optimizing their energy processes. And I did that as a graduate student, and it was super. Building optimization algorithms on a paper is one thing. Solving optimization problems as a homework problem is another thing. But taking optimization code or algorithms that you wrote in LaTeX, because that's really fun, giving it to a software team who implements it, and then seeing that those solutions are now being implemented in the field, in a facility where people are not experts on optimization, but just following this algorithm that you've built. It was extremely rewarding. And so we showed that we saved the University of Chicago something like $150,000 over 3 months through these algorithms. And that to me was like a spark. It's like, okay, I like writing papers, I like doing research, but I also like to have an impact. And so that company ended up raising $1 million from venture capitalists in the Bay Area and in Chicago and in Michigan. And so after I finished my PhD, I had the choice of a postdoc or the startup company. And so I ended up declining postdoc offers from MIT and ETH in Zurich and University of Michigan and other places, including Carnegie Mellon. And I just joined a startup company that was in Chicago and in Michigan at the same time. And that was a really fun year. It was very stressful. It was a very hard year. But it was really fun because I learned a lot. I learned about markets. I learned about energy markets. I learned about tariffs. I learned about boilers and chillers. I learned more mechanical engineering than I ever thought I would ever need. After a year, I'm still here. We did not become millionaires or billionaires. We didn't become a unicorn. It's very hard to become a unicorn, I think, in the energy business if you're making money off volumetric products like energy savings and efficiency. But the lessons were really powerful, and luckily enough, the University of Vermont were willing to hire me at that time. And so I did join the University of Vermont as a faculty in electrical engineering in 2014. And I guess that's how I got into academia. So that would be the answer to your first question. So are there any questions about kind of that beginning part?
Definitely. No, thank you very much for your introduction. I have a few questions more on technical side. I hope we can just jump for the technical part. It's mainly as the packetize, they have a solution for basic demand response, right? So you can control your device. But mostly of the solution that we have nowadays for demand response, they rely a lot of controllability of your device. You need like you can develop a really good algorithm optimization, but you cannot control your device, or you don't have enough number of device controllables. Your control just go down, and you don't have a big efficiency on that. So how are you dealing with this kind of challenge in the optimization on distribution and house systems?
So I the way I am interpreting your question is really about how do you implement algorithms in the field? Is that one way to interpret it?
Because you are providing an algorithm solution, but you also need a device that can be controllable. And nowadays you have just a few of them, right?
That's right. So I think your question is spot on, and actually, people realize that this is a challenge, including R1-7. So in 2014, R1-7 released a program called the Network Optimization of Distributed Energy Systems, nodes. And so, with my optimization and control background, we submitted a proposal based on packetized energy management to R1-7. When R1-7 decided to fund that proposal and turn it into a project, we launched the company in the side for two reasons. One, because the technology is amazing. We're really excited about it at that time. And number two, if we waited around for 3 years until the academic project was over, it's going to be too late. And so what we've been doing for the last 5 years has really been answering your question. How do we deploy innovative technology in the field at scale? That is probably the number one question we need to overcome if we want to make demand flexible, and if we want customers to adopt electric utilities, electric appliances. And so we've been working on exactly that topic. And there are two routes to take on this. One route is that you build hardware yourself that has the features, the computing capability that you need. So that means you're building an IoT device, basically, that can be used for retrofit, for example. And then what you do is you ship that piece of hardware out to customers that sign up for these utility programs, for example. That's one route. As you can imagine, hardware is hard already. The name is in there. It's hard. And so to get that to work, you need customers to be excited about it. The number one way to get people excited about it, if you're a graduate student, it's pizza. If it's other people, it's money. And so you really have to incentivize people to sign up for these programs, because otherwise people aren't going to do it for free. And also it motivates them a bit. And so, what we realize is that you really need to pay to engage with people, especially when it comes to their energy appliances. I don't know if you ever heard of the 2-pint problem, or maybe it's the creamy conundrum, I think we say in Vermont, or it's the Fenway Frank problem in Boston. The fact that energy is so cheap that if you or I worked really hard during a month to save on our energy, we would save $10 or $12 in a month. I go to Starbucks, I waste $12, in one sitting. And so there's not a lot of effort. You don't want to spend a lot of effort on $12. And so you have to make it effortless. And so if I come to you and say, hey, I have a new product for you, it only takes you 20 hours a month, but you will save 10 bucks, nobody will do it. It's the worst salary you can ever get, is energy efficiency. What we can do is automate it, right? If cars can drive by themselves, why can't our energy systems or our appliances drive by themselves as well? And so what we focus on at Packetize is really automated solutions. You set it and you forget it. And so the key we have to do is we have to get our device in someone's home, and we have to make installation very simple. And so what we're targeting here, what we've been targeting, what we've been able to achieve are our installations in half an hour or less, roughly, to retrofit water heaters, for example, so that they become controllable. And so we have about 500 devices in the field in Vermont right now, and we have contracts for about 8,000 devices in California and New York over the next year or two. And so your question about scaling deployments of innovative solutions is really one of the key questions we have to answer in the next year or two as we build out this technology.
And don't you think that this incentive can be from the utility? We know that demand response is really important to reduce your energy bill, but we can also work as an ancillary service. So don't you think that utility could also provide a money back if you have this kind of technology in your home, or this kind of incentive for the customers?
Yeah, that's a good question. The way you said it was, don't you think the utility could pay the incentives? Maybe if you flip it around and say, who gains from these technologies? And I think you're right, that right now the utilities are the ones that gain the most from having flexible demand or having batteries. Not because of advanced market interfaces, not because of DERM solutions, but because of peak reductions, right? Which is a monthly thing or an annual thing that has been going on for the last, 50 years. We've been doing demand response has been around for peak reduction for 50 years. You don't need Internet of Things to do demand reduction. But still, the biggest value is the utility. And so we've been working with utilities exactly around how to use these technologies for demand reduction, but also other things. And so, renewable smoothing is another benefit that we can provide. You put more renewables on your system, you can use flexible demand to essentially smooth out the variability. Instead of smoothing out variability, you can also respond to wholesale market prices. We call that LMP arbitrage, so locational marginal price arbitrage. Beyond that, you have much faster services that flexible demand could also participate in. So ancillary services and fast frequency response services are also something that we have shown that flexible demand can provide. This summer, we are going to demonstrate ancillary services with these packetized devices in South Carolina, which is super exciting.
That's nice. And you comment that you have some house that you're already testing your solution. So did you have any house in Texas in the ERCOT just to see what happened if the control was efficient in the Texas outage?
So we have not run those simulations. We don't have devices in Texas right now.
Okay.
So we have devices in California, we have devices in Canada, we have devices in Vermont and in South Carolina right now.
Okay.
And so we are launching new projects in California and New York starting pretty soon, which is exciting. But we've really been trying to focus on, A, making the technology better, and B, really exploring how to create value. And so if you focus on batteries, batteries are very famous, are very useful properties because they can stack value. And so they can stack value from many different market sources. And so, peak reduction is one, but it's a very boring service because it's a deterministic thing. You just discharge for 4 hours. You don't need a lot of AI for that. And so what we've been focusing on is really how to stack value for flexible demand. And like you said, it's control algorithms become important when you try to push a system to do more. And so what we've been focusing on is really with RPE and with the Department of Energy, we've really been focusing on, pushing the time scales at which our flexible demand can be responsive and provide value. And so we've shown in 2019, we had 156 homes in Vermont participate in a demonstration, not a demonstration, a test. It sounds like they were out demonstrating with us. But we were really just demonstrating our technology. And so we had 156 homes in Vermont validate that our technology could provide peak response, a peak demand reduction, and LMP arbitrage. So minutely time scale fluctuations we could manage with 156 homes. This summer, we're hoping to do a frequency regulation with about 150 to 200 homes in South Carolina. And after that, we're looking at, once that's successful this summer, we'll be looking at thousands of devices in California and New York as we scale up these two new projects we have.
Perfect. And can you comment a little bit more about like how's the relation about the packetized solution with the renewable energies? So do you consider that in the algorithm or just basically in the resultant power profile? How's the main relation with the DRs?
So with any control system, what we're trying to do is we're trying to track some signal, some reference signal. So what that means is if our reference signal is a renewable energy signal, we can track that or we can cancel it out with demand. If that was what we were given. We don't have a project right now where we do renewable smoothing. We have projects where we do LMP arbitrage. So we feed in the price signals coming from ISO New England. And then we have basically do an inverse of the baseline of the demand. And so as the prices go up, the demand goes down. And as the prices go low, the demand goes high. And so we're arbitraging our flexible demand to minimize cost to the utility. And peak reduction, of course, it's a peak reduction period. So there's nothing, no renewable fed into that. We don't have any feedback right now from renewables. But it could just as well be. If you gave it to us, we will happily manage that.
No, perfect. Yeah, I make the question because we see a lot of like demand response techniques applying microgrids, right? And the microgrids will have like a big influence of DRs. So this could be a really nice scenario of deployment, this kind of solution.
Yeah. So again, I would say that the algorithms should be built for their application. And so if you are focusing on a microgrid, you probably want to use different set of algorithms. Unless your microgrid is so big, like a state. Like if you're thinking of a microgrid, like a whole state can be a microgrid, which sounds crazy, but actually is what some utility executives have been talking about in the last couple of years, is to turn Vermont into one big microgrid. So basically to decouple, imagine taking a state and then decoupling from ISO New England. So Vermont will balance its own energy using flexible demand, local generation, and renewable generation as well. That could certainly be done. At that scale, I think our algorithms are still useful. At a microgrid scale, let's say, a military base or something like this, they're probably, because you have full access to information or microgrid setting, you can design controllers that are different. And so you can design maybe what we call a top-down control architecture, where you had full information available to you, and therefore perhaps you can respond more quickly, or you can do different things. But I would say, microgrid setting is probably not what we're focusing on right now, even if that is, quite interesting.
Oh, perfect. And you comment like about like some countries already have like a really small price of energy. So sometimes like it's not like worth you save a lot of like energy savings, like you spend a lot of money for your device. So do you think that with like demand response we are going to like face more and more the death spiral, or you think that we still are going to rely a lot on the utility side?
Well, that's a very interesting question. So I have personal opinions on that, and I have public opinions on that.
Okay.
My public opinion is that utilities are very important because they are what interconnect us all. Right? So the utilities are what keep me connected, not just to the grid, but actually also to my neighbors, right? I am electrically connected to my neighbors. So in that sense, they are what keeps us together. Right? They're the electrical glue of society. So what that means is I don't think we should get rid of that glue. I personally think we should rethink how we manage that glue. And so recently I've been very excited about concepts, you know, parallel concepts that are parallel to kind of how we manage communication systems. Right? So when you sign up for internet in your apartment or in your home, when you sign up for internet, you say, I want the 100 megabit per second service, right? Or I want the 50 megabit per second service, and then you pay accordingly. If you have a lot of flexible demand, or if you're an aggregator, perhaps, maybe you want to purchase the gigabits per second service from the utility. Maybe I want, as an aggregator, to have access to a certain capacity of the grid so that I can manage my flexibility within that capacity. And so I would say my overarching question would be this: are utilities uniquely well positioned to become the aggregators in the future to manage these devices? I don't, personally, I would say no, mainly because managing lots of devices, managing technology infrastructure that is relatively advanced is in the sense of, this is control and optimization topics. We're not building new transmission lines or power lines. I don't think utilities are the right people to manage and lead and innovate on those projects. Even if some utilities are indeed doing this today, there's just very few of them. So Green Mountain Power is probably the utility that's most forward-leaning when it comes to adopting technology, but they're not the ones developing it. And so I think the question we need to ask ourselves going forward is, what role should the utility play in adopting, promoting, and advancing technology and innovation in power systems? And what role do technology companies play in this, who may not be power systems experts, right? They may not understand the critical need and complexity of reliability, that we can't sacrifice reliability for the sake of innovation. And so there is a very interesting trade-off between utilities wanting to innovate and technology providers wanting to provide a reliable grid. And we have to mesh them together, and we probably need regulation, and we probably need to rethink market structures. That's not a 1-year project. It's a very fascinating topic, and I'm very excited to be working on this topic now. But it's a very good question you're asking.
No, perfect. Yeah, because mainly now with the Texas outage, people have been discussing what are the solutions for this kind of scenario, right? So we know that transmission is really expensive to create more lines in big power plants, and the utilities they are not like they wouldn't like to invest a lot of money on new lines and have like different paths to deliver power for you, or to have a controllability in your feeder. So the last option is basically the customer. So we know that the future, the PV are going to be like more cheaper. Some place you have small wind turbines. So we know the customers are going to have like more, like a big paper inside the utility. So some people that say that in the house you don't have enough like energy sometimes to have your power running, but maybe your neighbor, as you said, you have your neighbor to provide power to you, and you need to use the utility grid. So some topics they are discussing for the outage are microgrid formation. And for microgrid formation, you use all your neighbors, but you still rely a lot on your part of your feeder, and you still rely in utility controlling the reconfiguration, utility ensuring the protection. So in my opinion, I also believe that we are going to have like a utility, but in the long future, we might be alone in this kind of scenario. We have like a small community, and that small community have your neighbors with your PV battery, and we are going to run with more clean energy than connect the utility.
Right. I think your question is spot on. I think your topic, what you're saying, is really spot on, because I think it puts the role of the utility. I think that's the key. Like, do you need a utility that's enormous? Like, look in California, PG&E, SCE, huge utilities, absolutely enormous. Do enormous utilities serve their customer really well? Right? If they want to be customer-focused utilities, there probably is a limit as to how big they can get. Right? The bigger they are, the more removed from communities they are. And if a community then needs to ensure reliability or resilience, is the utility the partner to do this? Or does the utility need to either become smaller or have a relationship with community aggregators or community organizers to do this? I think that's a good question.
Great. No, perfect. Just give me a second. I'll get my charger here. I don't know if Ademir, Paul, do you have any question? We are mostly in the technical part, but we also have the startup entrepreneurship part to discuss. I think it's a really big challenge our electrical system field,
And
right?
I would also add that on technology, I think there's two types of technologies that you would need to look at. You know, transmission level technologies, I think, are very different than distribution level. So high voltage and low voltage, I think, are very different systems. And I do think, you know, when you look at when you look at PMUs, you know, the transmission system has done a pretty good job at adopting PMUs. They may not have done a lot with PMUs yet, but we certainly have pretty good observability of the grid today. The high voltage transmission grid, I think we're doing very well there. We have facts, you know, flexible AC transmission systems are in place. You know, I think the transmission system it's a good amount of innovation on the transmission operations. But I think on the distribution side, I think that's where the tools are really missing.
Perfect. Yeah, I remember my undergrad, like I saw like different, we have different students with different fields, and mostly the people that would like to be entrepreneur, they were like more in power electronics because you can develop a new inverter, new technology. The people from electronics, but never the power system people. They were not able to go like for entrepreneurship because the system is there. You cannot like hardly change your system. But now with like the smart grids and automation, I think we have a new field for us. We can create new companies as you are showing with Pactize. You can sell a kind of control algorithm just to help and make the grid more resilient, right?
So I think that's, so again, your questions are very good and your comment is really good. So if I were to, let me interpret what you said in my words here. It sounded like you said it's very hard for research or innovation to have an impact on transmission unless you are the transmission company. It's much easier to start at the customer's location if you want to promote technology. That's also probably why you don't see Google play around with transmission technologies, right? It's very hard to get into that place. Even as a PhD student, my work was focused on transmission. I had no idea how my algorithms could really be utilized or adopted by anyone in transmission unless you were GE and Siemens, who are the providers of the EMS software, for example, or the DMS software. And so I think in distribution systems, we have a chance to face people, right? You can have customer facing technology. So you can create an app that can interface with some IoT software that can make an appliance smarter or better for a customer. If you can then build out that technology and make your devices smarter, you can then control them and manage them. And so there's an entryway through people that I think is very hard to get for transmission, which is a real shame.
I had a question just as a follow up to that. What would be the ideal ending to, or at least the ideal scenario where how this all shakes out? Do you see this being contracted out for utilities as something they can add? Because they don't want to, like you said, they don't want to do this themselves. They're reticent to upgrade with such advanced technology. Or do you see this being marketed straight to end users, and then they would have a subscription service that they would pay on their end, and it's a little bit more labor on their side? I mean, you have to incentivize either end.
Yeah, so I would just echo here that utilities in Vermont you've really been, I think, forward leaning in terms of adopting technology, and their approach has been kind of like what you said, service based. So buying a battery up front is a huge expense, right? I don't know, $10,000 to buy a battery. Like a Tesla Powerwall is $10,000. Not a lot of people can afford $10,000, but in Vermont, you can essentially rent you can buy your battery for $15 a month, 10 years. $15 a month, that's Netflix, right? What makes Netflix popular is that I don't have to pay for everything I watch. I pay one fee and I have access to an infinite library that I can never find anything to watch because there's too many things. But the utilities can adopt the same role where they say, if you want access to technology, all you have to do is subscribe, right? It's a different marketplace, but it's very simple. And if you can afford Netflix, you can afford a Tesla Powerwall, which means now you have reliability against storms. You have basically will never have an outage. And I would love to see them do that on electric vehicles too. Of course, the downside of signing that $15 a month is that the utility gets to control the batteries for grid services. And so they can't promise you upfront that you have the energy when you need it, but they will try as hard as they can, using somebody's algorithms to manage the batteries, so that if a storm is coming, they will charge the batteries up and prepare you for that. But otherwise, they get to play with the batteries in whatever markets they want.
Wow, that really is the nimble kilowatts right there. Being nimble by shifting where it's needed and using predictions, and that's amazing.
Yeah, so that's happening in Vermont. I think there's about 2,500 Tesla Powerwalls deployed in Vermont, which is the most in any utility, I think. Which is really amazing. I mean, that as long as you trust Tesla to do a good job, I think the interaction between utility and technology company is exciting. I can only imagine what that program would look like if a utility tried to deploy batteries themselves and manage those algorithms. So yeah, I think service flat fees, $15 a month. I think that's as affordable as it gets.
Yeah, even like some utilities, they have been provided some kind of like fees for if you have like a renewable energy, a battery or PV system in your home. Some utilities they are like doing some agreements where if you have a kind of situation, you need to provide at least this amount of power back to the utility. So they are moving for a new kind of agreements with the customers as well. I think this can be like also a good future just to ensure that you have like a reliable distribution system and you can make sure that during a situation you can have this kind of energy, this amount of energy back.
That's right. Yeah. So net metering, is that net metering?
No, I was discussing with my advisor. I think it's a company in Australia. They are doing like more agreements with the customers. So if you have like a kind of situation, you have agreement that you're going to provide this amount of energy back to the utility, and you can have a battery or you can have a solar system.
Okay.
Yeah.
So Australia is definitely one of the other areas outside the US that are certainly innovating when it comes to solar PV and integration and how to marry that with batteries.
Perfect. Yeah, I think that is a good solution for the altitude systems, right? So if you have like if this kind of microgrid formation technique go over the future, you also need the support for different neighbors. Your microgrid like is not going to be enough if you have just a diesel generator or your utility to have a big battery, but you still need this small source for each customer. And then to make sure that the customer is going to share this amount with the neighbor, you need to have agreements. So this is also a topic that we as engineers sometimes we are afraid to face. That's like more like laws and it's not like that technical part, but more economy and all this stuff. But we
No,
actually we need to face that, right?
I totally agree. Totally. So as engineers, sometimes we like to hide in equations or physics, but we have to remember that the power system as a system is an interaction between engineers, physics, markets, people, and most of all, I guess, regulators. So policies and laws make up a big part of what is the grid today. And so, even if you have the best solution, technology solution, or the best engineering solution, it may not be a solution for the power system. And so, yes, you're perfectly correct. We need to, as engineers, I think it's important we study a little bit macroeconomics or microeconomics. It's probably a good idea to listen to folks talking about regulation or policies, energy policy. because in the end, your solutions have to fit within that lens. Even if you're trying to do something, fun, like a startup company called Packetized Energy. So be well-rounded, but don't just study the mathematics. If you study optimization, right, a zero duality gap is not the solution to all problems.
Perfect.
Totally agree.
Perfect. That's great. Can you speak about like how was your experience like to create a company? Like what kind of challenge like this did you face? Like what like, new topics that you were required to learn and when you go for a
Yeah.
company in real world?
So that's a good question. That's a deep one to have to think about a little bit. So starting a company, is actually pretty easy. So I think as there was myself, it was Paul Hines and Jeff Frohlig. We were three co-founders of Packetized Energy Management, and we basically founded the company in May 2016. And it's surprisingly easier to found a company. It doesn't cost a whole lot of money, and you can set it up in Delaware. So we did that pretty easily. I think the hardest part with any company is understand who are your customers. So first understand who are your customers, and then understand what problem do they have that you can solve. And so we spend a good amount of time really focusing on what are the problems that our customers are having that they're willing to pay for. And so we've focused on utilities quite a bit. That has kind of been our focus. If anyone is in a startup company focusing on utilities, trying to sell hardware, it's very hard. Utilities are very well known for being risk averse, right? The very good reliability we have today with our electricity is in part because the utilities are risk averse. When it comes to adopting technology, it's very hard to convince these folks of why they need new technologies. And so the conversations with utilities take a long time. We call it sales cycles. And so they go from 18 to 36 months. Right? So if you don't know the utility up front, it'll take about 18 months to 36 months to sell to a utility. Whether you're selling batteries, whether you're selling a new program for flexible demand, or whether you're selling them some weather forecasting app. It takes significant time to sell to utilities. And so that's something you learn in the process. So how to speak with utilities, how utilities work, not on the solving KVL and KCL loops, but really how do they work in terms of their economics. Is really useful thing to learn. And I've spent a lot of time in conversations with utilities, in conversations with our co-founders and our team to understand how to value a product. Like if you want flexible demand to be valuable, you have to be able to provide some service that a utility is currently paying for that they don't have to pay for with you. And so you really have to dig in to understand, what does a utility pay for today, and where can you help? And that is really hard to solve. The other option is, do we sell to individuals? So do I call you up and say, hey, I can give you $50 a year if you let me install this device. And then I have to now come up with reasons why you get value from saying yes to this. Okay, so I have to think about energy efficiency. I have to think about what do we derive value from as individuals. So I don't know if you have a Nest at home. Okay, so I have two Nests at home, one on the one floor and one on the bottom floor. And in the summertime, nothing happens because I don't have air conditioning. Right? In Texas, that's crazy. In Vermont, that's okay, more or less. In the winter times, they start fighting each other. So in the beginning, Nest used to have this AI, a machine learning algorithm, whatever it does, that would change the set points ever so slightly. And so I kept feeling cold and hot. And so these darn Nests were basically fighting each other because they weren't able to coordinate between each other at that time. And so it was very annoying because they kept changing the set points. And so I did not get value from that. right? Even though their app is pretty cool and I can sit, if I drive, so the value that Nest provides is this: if I drive for vacation and I forgot to turn off my heat, I can do it on my phone. And so now I'm not wasting energy. Um, the other thing the Nest is really good at promising is energy efficiency savings. And so they claim something like, I don't know, $200 every 2 years or something like this in energy efficiency savings. I don't know if it's true because I don't know how they decided that it's $200 because they have to build a baseline to guarantee that. But they claim energy efficiency savings, and I'm sure they can deliver it. And so if you do flexible demand, you don't necessarily want energy efficiency and flexible demand are not necessarily one-to-one.
Perfect.
So
And like this relation is really interesting because you try to sell a product for the utility, but the utility are like so they are not like flexible to accept this new technology. So you provide this for the customers. And I also bring like one experience with me, like I work in the utility in Brazil, and this information is open, so there is no problem. But they start to have so small PV panels in their in homes, but they were just mapping PV panels over 75 kilowatt peak. The smallest one, they're not adding their system. But it was like so quick, so many people adding the system in their homes that like there was like one moment that the state estimation was not converging. They are not like finding the state of the grid anymore because they have so small generation over the customers. And I think for demand response, something like that could happen in the future maybe. Like you have like your customers more and more dynamic. You don't know when they're going to turn off, because we used to have the traditional power curves to see how the customer is going to have like how will be their behavior. But with this demand response, we cannot predict anything. So this maybe could be something that can happen with the utilities. They start avoiding right now, but maybe in the future they need to have some communication with the customers just to know what's going on in their load, right?
yeah, or maybe even take it one step further. I think utilities have to work closely with technology companies because as you said yourself, there has to be some information that the technology company can provide the utility so the utility can do better. And there's some information the utility can provide the technology company so the technology company can do better for the customers. And I wonder if some company soon will come up and say, hey, maybe that transfer of information can be, there's value in that, right? Maybe we can increase reliability if the aggregators tell us more about the device's status or the grid status in different locations. So you can get observability at a very fine granularity from aggregators. Right? So think of a company like Enphase. They build micro inverters. Each of those inverters are like eyes and ears on the grid. If Enphase could share that information with utilities, I think utilities can do a lot better managing their grid. If the grid operators could tell Enphase, what is the grid status right now, or where do we need load relief, or where do we need curtailment? I think Enphase could do even better. And so there's a what's it called, symbiosis. Both players can gain value from exchanging information, and therefore that information has value. Maybe that's the way we do it. Utilities pay aggregators for data to manage the grid better. And so now they're friends working together cooperatively, rather than, like what you said, potentially competing, right? Where I'm suddenly playing with my electric vehicles as an aggregator and now I'm hurting the utility. And by hurting the utility, I'm hurting the glue that connects us all. And so if somebody gets a blackout because an aggregator, tried to maximize revenue from electric vehicles charging, this doesn't look good for anyone.
And actually, communication technology is not anymore like a challenge for us, right? Like the utility have this radio, internet, fiber cables, so it's not like the communication challenge, but mostly accept these and organize this kind of technology, right?
I think there's, so on communication, there's one big gap that actually is today is there really is a lack of communication standards for these smart appliances. So IEEE, I think, have done a fantastic job on inverters, right? We have IEEE 1547, we have UL 2030, was it 2040? We have standards for inverters. We know how they could operate. We have almost no standards that are suitable for smart devices on the communication side. So like DER communications, there aren't any great standards that don't assume you're the utility. So there's like the IEC 61850 is a pretty good standard, but only if you're the utility. It works really well if you're the utility. Utilities have in many cases, utilities use fiber optic or a local network to manage their communications. That also works pretty well, except it doesn't go into people's homes. And so it kind of stops at the meter. And a lot of aggregators use Wi-Fi or cellular connectivity, which is going around the utility. And so the question becomes, which platform do you utilize? Which communication platform do you do when you want to manage smart devices?
In the packetized, they are using mostly what kind of protocol? They have different protocols to integrate in demand response, or they mainly focus on one?
So you have to unpack that one a little bit. Packetized exists as a platform. So our company provides a DER platform or a grid edge platform for flexibility. And so that platform exists in the cloud. So we work with Amazon Web Services, for example. And so Amazon Web Services has requirements on security with communications between the cloud and any devices. And so that's for example TLS 1.2, which is state of the art. Our devices themselves have hardware level encryption, which means if you want to hack our devices, these internet controlled devices, you need basically an electron microscope with you. Which again, hardware level encryption at the device level. You have the cloud with TLS 1.2, which is security layer. So those are kind of the security platform. This is cybersecurity. And of course you have, what's it called when you get a text message to authorize yourself? What's that called?
I don't remember now.
Multi-factor authentication. So that's there. There are some standards for automated demand response. So OpenADR is a standard that gets fed into, which is a signal that goes from the market or the customer to our cloud, which basically manages how flexibility should be managed. So it's called OpenADR. And so what is still missing is the cloud to devices DER protocols. And so the one thing we didn't mention earlier actually was, instead of selling hardware to people, what if I can work with your thermostat manufacturer and just go through the cloud? A lot of devices today are already smart, like smart thermostats exist. So if I could work with Google directly, I don't have to deal with you. I can just work with Google, and then we both go through the cloud and we do a cloud to cloud communication. So an aggregator cloud to a manufacturer cloud to manage devices. That has other challenges as well. But cybersecurity is a big concern. I think in the next 5-10 years, if we become more and more distributed. And the question about who owns the data, utility or aggregator or owner, a device owner, becomes also a challenge.
Perfect. And that's really interesting, because one of the main challenges for the demand response is deal with different protocol communications and all this part. But if you have everything in the cloud, it's really interesting because you don't deal exactly with the underground communication cabling, all the stuff, right?
That's right. You just need to you need the right sensors and actuators in place at the device layer. So the device has to be able to do what you want it to do.
Perfect.
So surprisingly, there's smart thermostats, for example, don't measure the kilowatts of the devices they control. So there's no electric meter that manages that kilowatt. And so if you want to manage smart thermostats, where do you get your kilowatts? How do you know that when you manage the thermostat, you actually got a change in kilowatts? There's no measurement. And so
don't have feedback.
There's no feedback, that's right. So you need creative approaches. And so you need additional sensors.
Perfect. Sometimes you can emulate the device, but you don't have the actual feedback from the house, right? From the customer.
That's right. So you can do, machine learning or regression or system identification can be used
Mhm.
to infer or to estimate whether or not the device was consuming and how much the device was, the HVAC system was actually consuming in the summertime, for example. You
Mhm.
can infer that, but it requires additional data as well.
But there isn't any kind of like constraint for the control, like the minimum like measurements or the minimum device, or can you briefly just approach like
So
what
the
kind of
so
constraints
so
to
so the key
packetize?
yeah,
Mhm.
that's the right. The key constraint to managing these kind of smart appliances, it's really the human, right? So if I'm managing your devices, if you get a cold shower because I mismanaged your what's it called, water heater, or if you
Mhm.
are uncomfortable in your office or in your home because I am basically managing your thermostat incorrectly or improperly, you will become uncomfortable. You will basically just push a button on your phone that says opt out,
Mhm.
right? So in California, utilities lose 20 to 25% of their demand response fleet of smart, the air conditioner program they have. So they lose thousands of customers every year because they're uncomfortable. And so they basically have full turnover every 5 years or so. Every 5 years or so, they have to re-get their people um, into these smart AC programs. And that's because, if you're uncomfortable once or twice, those $5 a month is not worth it.
Right. Makes sense, makes sense. All right. I don't know if any the things have any question. Feel free to drop the chat, uh, join the discussion as well. It's really interesting because here in Texas Tech, we are also working demand response. We have a project with the DOD, sorry, and they are mostly working demand response for military base. And one of our challenge is just like how to ensure the comfort rank of the users, like how to ensure that the user is going to be comfortable with like this demand response. But we are moving for like different device, so like a plug-in device controllable, thermostats, also HVAC, but electrical vehicles as well. So we are
Is
trying
it
to do
is it a
simulation
hardware?
side as well.
Is it hardware or software? Are you simulating or are you putting it in the field?
No, it's harder. Yeah, we are using Raspberry Pis. The proposal of the project's mainly like develop some like really cheap tool that you can just like integrate different communication protocols and you can develop actually a demand response. So for now, we are using the Raspberry Pis and we start with some hardened loop simulations with OPRT, but we are moving to work in our laboratory. So in real device, we have like some real device to get him the real measurement and try to control. Is one
Very
of
good.
our
Very cool.
challenges. Yeah, like I didn't know a lot about packetize it, but I started taking a look at, for me, like the most interesting of the company is how it like answers in real time. So you don't use any kind of like predicted power consumption like profile. It's just real time. So this is like really incredible.
Yeah, it's really the power of we're making so a packetized energy management. A packetized energy, what we do is we focus on the devices. So if you make the devices smart enough where they can take care of their owner, then they know when they have something to offer, right? So if I know, oh, my owner is happy right now I have some flexibility, right? I can provide some flexibility. I can turn off my water heater right now if you need me to. And so what we focus on is if the devices tell us what they can do when they can do it, then all we have to do for coordination is listen to the devices.
Mhm.
And so, it's asynchronous, which means the devices can communicate to the cloud whenever they want to, of course, whenever they need to, right? To limit communication costs, you don't need to communicate all the time. And so we are relying on the devices basically providing us with information about the flexibility of the fleet. And so if we listen to the devices, you can think of it like a signal.
Mhm.
The greater the intensity of that signal, the more flexibility there is. And the way we've designed the device logic, we can actually estimate how the fleet is doing as a whole. So it's almost like we can estimate basically or infer the stress of the devices, so whether or not they're able to meet their customers' demands based on how often and frequently they communicate with us.
It's
So
really
there's some really nice. We've written a couple of really fun papers on those topics, um, which have of course been happening in parallel with actually implementing this um, the project and the company over the last 5 years.
It's really interesting, yeah, because like sometimes the predictions like you have small errors and you don't know exactly how to schedule your load. Like sometimes you are messing with the customer, but what they'd like to do. So in real time is really nice. It's a really good solution. Can avoid a lot of like issues, right?
It solves a scheduling problem in real time, basically. So you
Yeah,
don't have to optimize thousands of devices, which is a hard problem to solve.
that's perfect. It's perfect. So I don't know if everyone have any question. Uh, the guys here in the panelists or the attendees.
Yeah, I got a question. Maybe like circling back to the beginning. I guess my question is, what is the best way for, because most of the guys here, the participants are either undergraduate or graduate students. What would be their, how would you recommend the best way for them to start their journey in entrepreneurship, specifically in the power industry?
So um, so the best way to start is with internships. Uh, those internships exist. And so getting some experience. So my experience came I was basically as a graduate student, I was a part-time consultant for this startup company that didn't exist yet. And so I wrote optimization algorithm as a consultant, which was really fun experience. That was my internships while still being a graduate student. And my advisor was okay with it. So ask your advisor first. So internships are totally fine. There's lots of job openings. There are really quite a few job openings at companies that are oriented towards kind of an innovation or technology angle for power system problems.
Mhm.
Tesla would be one.
Yeah.
But there are lots of other ones. Sunrun, Opus One, Packetize. We usually have interns in the summer, especially when COVID wasn't around. Kevala, Smarter Grid Solutions. There's a lot of companies. So I would say find that list of companies, and that's not too hard to find. Number two, listen to the Energy Gang. So the podcast called The Energy Gang, that is a really good podcast that covers kind of the policy angle, the technology angle. You can find those folks there. There's another one called The Interchange.
And I'm sorry, that was Energy Gang? The name of the
Gang,
podcast?
like
Alright.
a violent gang, but these are kind of nerdy
Okay.
gang. So those folks are really good. And so apply for jobs. If you want to start your own company, I think focus on the sensing. The sensing element is really important. What can you measure? And once you know what you can measure, then you can think about what you want to control. Starting your own company is definitely a lot harder than joining one as an intern.
Yeah.
So start with an internship.
Okay. All right. Thank you.
That makes sense. No, perfect. All right, thank you very much. We are a little bit over time, but I really like to thank you, Matt, for your time, for this really amazing conversation here. We have some lightings and some really nice topics to discuss. The idea of the session was like that. We have just some discussions, bring some topics, like see different opinions. And I think like this brings a lot for our formation as students, undergrad and grad students. So this is amazing. So I really like to thank you very much for your time and consideration to be here today. I also would like to thank Ademir, Paul, and Clinton, the three guys of the team here that make possible this session today. They have been helping a lot in the monthly podcast, and they are also like IEEE PES volunteers. So we have a great team here, and we are looking forward for future sessions with you, Matt. And thank you very much for your time.
Thank you so much for inviting me, and thank you for everything you guys do. I just came here and talked. You guys planned this event, and you're planning other events. So that's really important, and I strongly support you guys. If you see me at a conference, say hi. Don't be shy. And if you need me for anything, I'm happy to help out.
Definitely. Thank you very much. Thank you very much, and have a good evening there.
Thank you very much.
Thank you.
Take care, everyone.
Everyone.
Yeah.
Bye.
Thank you.